Hi everyone, thanks to be here to talk about zero-downtime deployment. So thanks to Vladuc here, I should greet you with Ce faceți pisicuților. Works for you? That's the only Romanian that's the only Romanian that can be recorded that I know. So I'm Nicolas Frankel. I've been a consultant for a long, long time in consulting companies, and a bit more than 1 year ago, I switched to developer advocate. I've always worked in the Java ecosystem, Spring. I'm interested in Kotlin. I'm also very interested in DevOps. And well, if you have been a consultant, if you are a consultant, you know also that communication is not so easy sometimes, so DevOps is interesting. And of course, right now, DevOps from the technical side means Kubernetes. I work for a company called Hazelcost. So who knows about Hazelcost already? Hey, great. Who uses Hazelcost already? Great. Come talk to me afterwards. And we have our product, our main product, our first product is something called IMDG. So in-memory data grid, and basically you can think about it like data structures. And upon that, we built a stream processing engine, so-called JET. So if you're interested, please have a look. So, question, why zero downtime? The first is because of you, probably because just like microservices, you want to put zero downtime algorithm because it looks cool. Who here doesn't want to do zero downtime? Yeah, everybody does. You want to do zero downtime because it's cool, because it makes your value higher on the market. Also, people, everybody expects zero downtime nowadays. Your grandmother perhaps uses Gmail or Facebook, and when was the last time you came upon Facebook or Gmail, and then there was this little page saying, hey, please come back in a few minutes? Nobody. I mean, I don't remember the last time. Well, I don't have Facebook, but that's something else. There was an issue, but it was not planned, it was unplanned. Zero downtime is for when you want to plan. And finally, the last category of people who might want zero downtime is the business. I've worked in e-commerce at some point in my career, and basically when you do e-commerce, you want to sell all the time. And every time when your site is down, you cannot sell, and customers, potential customers, they go to another site to buy. So zero downtime is just newly mandatory. And of course, everybody here knows how to do zero downtime. There is this old stuff called BlueGreen Deployment. You have two completely similar environments, one called blue, one called green. One of them is production, one of them is pre-production. And then when you want to deploy a new version, you just switch. It's super easy, right? That's what architects tell you. Hey, let's do that. And I mean, then we have those ops or those developers that can implement that, but it's easy. Of course, you might comment that might be a little problem regarding the database. So here I have two different instances. Oh yeah, it's easy. Yeah, just have a simple database, a single one, and everything is fine. However, if you really check the detail, the devil in the detail, there are some problems. The first is when here I switched, I just clicked my clicker and I switched. However, between the time when you click or you run the command line and you really switch, there might be some delay. That might be a problem. So the routing latency is an issue. Also, if you think about it, what about customers, users already using one environment when you switch to the other one? What should we do with them? I mean, that's an issue. And the third one, as I mentioned, is a database. So either you try to think about migrating all the data, or you need to make everything compatible, schema compatible. And as I mentioned, Kubernetes is very hype right now. And with Kubernetes, you can have rolling updates. So you just have your 1.0 instance, and then in a rolling manner, you just update to 2.0. And there is something called a deployment. And in this deployment, you just set the strategy that you want to use. In general, it's a rolling update strategy. So you have two parameters. The first one is the max surge. So how many additional pods can you provide? And the max unavailable. So how many pods can you make unavailable? So here I have max unavailable 0, max surge 1. So basically what I will do, I will create a new pod, deploy the new version, and then I can bring the count down to 1 less, which will be one of the old pods with the old version. And then I do that until all of them have been replaced. On the opposite, if I don't have so much money, I must keep the same hardware. I don't want to spend more. I can have max unavailable 1 and max surge 0, and then I do the opposite. First, I remove the old pods. Then when one has been removed, I can deploy one more with the new version until all of them have been replaced. And of course, it's not only those options. You can mix and match, so basically you get faster. Okay, you might tell me, but the apps they don't start instantly. So we need to think about, just deploying, just scheduling them in Kubernetes semantics is not enough. The app must be ready to actually do its job. Okay, but Kubernetes allows that. And if you are using Spring Boot, who here is already using Spring Boot? Yeah. Spring Boot has the actuator endpoint, and one of them is a health endpoint. So it's just a matter of wiring them together. You have the readiness probe, you have the health endpoint, and it's done. So when the application is healthy, then just direct request to it, and it's fine. Great. That's the end of the talk. Well, that's the end of most talks, actually. Kubernetes solves all your problems. Everything is fine. But if you really thought about it, what about the database that I mentioned previously? So if you now take care of the database, it's not as easy as just, hey, let's create a YAML with deployment and everything will be fine. So if I roll out new versions here, it doesn't work like that. Because as soon as I try to upgrade the database schema, then I've got an issue with the old version. So the thing is, consecutive application version that must be schema compatible. Okay, so the new version must also take into account the old schema, and the database schema should only be upgraded at the end of the process. Problem solved. So we upgrade every node, and at the end, that's the problem solved. End of the talk. Again. But the issue, again, is what if I need to roll back? I know nobody needs to roll back ever. We are the greatest engineers. We test always 100%. We never need to roll back. But what if you need to roll back? If you need to roll back, you cannot. So the problem still stands. And then it becomes not a Kubernetes or DevOps problem. It becomes a developer's problem. So you must design, if you want to achieve zero downtime, you must design your application so that the changes, they are both forward and backward compatible. Now it gets super, super hard. I have a simple use case for you. Imagine that I tasked an intern to create a database schema, and yeah, it never happens in real life because yeah, we only have like real full-fledged employees. But here, I was an intern. I had to create a schema, and basically what I need to do is I need to separate the table into two different tables with a relationship, because for whatever reason, my schema was not right. So that was my initial schema. So I skipped the database design course when I was in university. I put everything into the same table, and now I want to migrate to something like that. Make sense? And basically, it's not backward and forward compatible. But I still need to do it. So we will break down this non-compatible change into like a pipeline of steps that are compatible side by side. The first step, we will create the address table. And every time we do a change on the person table, we will actually replicate the change on the address table. So if we don't need to go further, if we need to roll back, we have like additional data in address that is not used, we don't care that much, that's fine. The second step will be to actually set this new table as a source of truth, and again, replicate every change that happens on this address table on the person table. If we need to roll back, all the data will be in the person table. That's fine too. And then in the end, we can like basically clean up everything, stop copying the data, remove the additional columns and stuff like that. One hiccup along the way is that if you are using Spring Boot makes your life easy. But it makes your life so much easier that basically it creates a schema for you. And it updates the schema for you. Meaning that if you let Spring Boot handle all schema changes, then we will get back to square one, meaning A, not compatible. So what we need to do is delegate it to a tool that is dedicated for that. So there is Flyway, Liquibase. Who knows about them? Oh, amazing. So Flyway and Liquibase, I chose Flyway because I know the guy behind Flyway, but it's just like you can use whatever you want. It's just like versioning for your schema. If you don't use it, you should really, really consider using it. Like, yeah, you have your sources under version control, but you should have your database under version control as well. And the concept of Flyway is based on migration. And the migration is just a SQL script. The migrations, they are ordered, and basically they are executed in order. Migration that has already been executed won't be executed twice. And that's all. I mean, that's really, really all there is to know. There is something that I have been bitten with. To make sure that, yeah, a migration has been executed, Flyway records it in your schema, in your own schema, under its own dedicated table. If you try to be smart and say, I missed something, I will change the script, a migration that already has been executed, it will complain a lot, because it not only records the name of the script, it records the hash of the content. So if you change the content, new hash, and then bad stuff happens. Don't do it. Don't try to be smarter than Flyway. And the great stuff is it's integrated with Spring Boot. So basically, you just have a dedicated folder where you put your scripts, and the naming of the script makes the order, and then they get executed in sequence. And again, if it has already been executed, it won't be executed a second time. So you can have different nodes trying to execute the same stuff. The first one will try it, we execute it, the other say, oh, it's already been done, fine. My application is a standard application, so I was trying to use GPA for the replication. Another way to do it is to use triggers in your database. I'm not a database engineer, I'm a coder, so basically I try to do everything with GPA. It didn't work out. There are listeners in GPA, but the problem is they cannot be injected with Spring. So basically I had to resort to dirty and cheap tricks and go down one level, the abstraction layer, and directly create Hibernate listeners. You know, there is a whole event-driven model inside of Hibernate, so you can listen to changes and stuff like that. That's really good. Okay, who wants to see some code in the end? Because, I mean, it's super boring so far, right? Yeah, that's what I thought. Okay. Not this one. This one. So I created an application. Start.spring.io. The only stuff that I used Kotlin because I mentioned I love Kotlin. Who here knows about Kotlin? Yeah. Who here uses Kotlin? There is room for improvement, let's say. Okay. Anyway, so good thing about Kotlin, I don't need to put a static main method inside of class because, yeah, we are object-oriented in Java, but in the end we put in a static method, which is not really object-oriented, so just put it at the top level. Here I created a person controller. I have a get mapping, so basically, yeah, I just get the person out of the database, and I create a new person. I don't have any update or delete because the rest is just easy. And my model is pretty stupid. It's just a simple person, and it just mirrors the schema that I showed you before. There is an ID, there is a name, there is an address, and blah, blah, blah. Okay? So what's the first step if I want to containerize this application? Docker file, yeah, of course. So you hear containerization, so you think about Docker, and the next step is to create a Docker file. Well, I'm lazy. I don't want to create a Docker file, especially since probably all your Spring Boot application, even perhaps all your Java application, will be the exact same Docker file. So because I'm lazy, I will be using something called the Gib plugin. So it's a Maven plugin. If you really, really need to, there is also a Gradle plugin, but of course you should prefer Maven, but that's your own personal preference. And by default, everything will be worked out for you, so it will publish your stuff to Docker Hub, but because I don't want to publish my stuff to Docker Hub, I will just publish my stuff to my local Docker runtime, and you can also define which base image you want to use. If you don't tell it, then Google will use its own, which I don't like because by default there is no debug, so it's not super great. Then I will use this one, which allows me to shell into it if there is an issue. So that, if you always find yourself like creating the same Docker file again and again for Java project, just use that, and it's like very, very stupid. As I mentioned, I have created my migration. So before like creating my migration, I would just say like I will just disable the auto generation. And now I have created this migration, which basically creates the schema. So now everything is mind control. I am responsible for that. And because I'm also a bit lazy, I just insert some data so that it makes the stuff easier. Okay. So I already have the, I must show you first the deployments. So I have created 2 deployments. The first one is the database deployments. Are you familiar with Kubernetes or not at all? Should I describe the deployment or is it fine? Should I describe it? Yes, okay, I will describe it. So first, I'm a good citizen. So if you are a developer, you put your code in package, you don't put it at the root. Though here, the same, you create a namespace, then you only do that into the namespace. Then because like what happens in Kubernetes stays inside of Kubernetes, and actually I want to use it outside of Kubernetes, I need to expose it to the outside world. I'm not using the cloud, I will be using my own computer, so in that case, I just create a node port that tells me, hey, I can access the foreign service outside of it. And finally, I will just use a version of H2, which is like standalone. So I will have a H2 server. So I could use MySQL or whatever. I use H2 because H2 is easy. This gives me the following. Now I need to reconnect, of course, otherwise it would be too easy. And then what I need to do is I need to go on that and copy-paste that one. And when doing that, I can finally see that I have a brand new schema. Nothing is here. So this is a database, and I have one single database. And then I have like additional my application that I created previously, so I don't need to do it because it takes a bit of time. And here I have this rolling update stuff, and I have 3 replicas. So basically, I will try to roll out those 3 replicas. The first one that will get the hand, I mean, I don't know which one is it, I don't care. We'll try to execute the Flyway scripts, the Flyway migration. Meanwhile, the other, they will stand by. And then, in the end, normally everything should be fine. Should be because it's a demo, and of course, there is risk involved. So now I should apply this application stuff. And normally, it will tell me that stuff is happening. Hopefully. Yes, yes, yes. Perfect. Now if I get on here my information schema, you see the person schema has been created, and then Flyway has created its own one. So here it told me, hey, I have executed this script, everything is fine. And if I go on my application, so it takes a node, a pod randomly, and you see there is already one line. I can create my own, so I will create Jendo, and everything is fine. Okay? Now, this application is super successful for whatever reason. And I want to migrate the schema. So as I mentioned, the first step is just to create the address table, and then to copy everything when something happened on the person, like to trigger the change in the address. So this is the address entity. It's just like nully a copy-paste of the person without the name of the person. Because I'm using Kotlin, I created an extension property. That's super cool. If you don't know Kotlin, just check that. Just for that, it's worth using. And in the end, as I mentioned, I created the listener. So basically, when I insert a person, I will save the entity. Works for you? And now I will apply that. So imagine I build the application with that in mind, and I will try to apply this first one. So normally I should be very, very fast and try to show you that there is no downtime, and sometimes there is for whatever reason, because I'm using H2, but normally everything should be fine. So here it started deploying the stuff. You see, it killed the 1.0 pod, and then because it killed, I'm still redirected to another 1.0 pod until it will kill this one. Always time. Yeah, and now I'm redirected to this one. So I missed a request, sorry for that. Sometime I will check why, but here, normally it should be transparent. Now, all of my nodes are completely, all of my pods are completely 2.1. And now, with this new schema, I can try to, I don't know, like create a new entity. It still works, so this is compatible. And here, you can see that the address table has been created. On the person, I have several entities. And because now every change I do on the person is replicated on the address, and because I created a new person, I have stuff in the address table. At some point in this talk, in general, people ask me, well, yeah, but I mean, why didn't you duplicate everything from the person to the address? Because now I'm not sure I want this state. Perhaps I want to roll back, and if I replicate it now, then it would be useless if I roll back to the person table. The next step, however, will require me to migrate. So I will check out that one. So here, now this new migration, remove the constraints, adds constraints, and do the migration. And normally, I should check here, it's to the 2. Now I will migrate to this version. I can still use it. So meanwhile, normally I should see here. So here, migration has been done by the first pod. Now it starts other pods. Yes. So now I am 2.2. And again, I can write new entity. It still works. Now let's do something crazy. Let's imagine that your tests prove you now in production that it doesn't work anymore, you need to roll back. So let's try to do the rollback, because the third step is not very interesting, is cleanup. So here, what we will do is we will roll back to 2.1. Normally, every migration so far has been executed. So Flyway should do nothing. So the only thing now that is required is for Kubernetes to do its stuff. Shouldn't work like that. It's 2.1 normally. It's already running, so it's a bit fast for me, for my taste. Yes, oh no, it was very fast. It was so fast, I was like amazed it worked out already. And I can still create stuff now. Let's say, so everything is still compatible. Now, if I want to go further, I can directly go to 2.3 because all stuff has already been done. But because I'm really paranoid, I prefer to go to 2.2 again, just to make sure that everything should be working. Takes a bit of time. That's the problem with your local machine, is basically, perhaps I should create an ingress that goes round robin, because yes, here now it works again. And now I can finally say, okay, now that's fine. I will just do the cleanup. And after that, then everything will be in the final state, the state that I really wanted in the first place. Just prefer to watch. Yes. I lost one request. Basically, I think I know the reason is because the health endpoint doesn't tell me if the migration has been done. It just tells me, hey, yeah, the application is up. That's fine. So then it uses the old schema. So I should probably either not use the health endpoint or use create an additional constraint, an additional health check that checks that it's the right stuff. But again, I'm too lazy. And then it shows on the demo. So conclusion. Zero downtime is possible. You can do it right now. There is no real roadblock that prevents you from doing it. It's not only Facebook or Google that can do it. You can do it in your own company. But don't listen to people who tell you that just use Kubernetes, or just use microservices, or just use Agile, or whatever new keyword just will happen tomorrow, and everything will be fine. It requires a lot of effort to do zero downtime. It requires you to think about the change that you are about to make, and if the change is not compatible, to break it down into those baby steps of forward and backward compatibility. This involves not only the designers, the developers, but also the project managers. And now imagine that you do that for your 20 feature branches. It's going to be a lot of fun when you need to merge that. This is not a trivial example that I show you, but it's a simple example anyway. And yeah, you need to think a lot. Now imagine you multiply it by the number of feature branches. You might get into trouble. Also, don't forget to clean up afterwards. So while it's possible, it has a definite cost, and as good engineers, you should always provide your business owners with the cost. Yes, this is a benefit, but we must do this, and it costs that and that. Thanks for your attention. You can read my blog, you can follow me on Twitter, and more importantly, you can get the sources for this demo and play with it by yourself. And perhaps create an additional else check so that I don't need to do it because I'm lazy again. Are there any questions? Yes, there is a question. Is there a mic for the gentleman? Yes, great. Thank you very much.
Hello. So, do you know if Flyway applies the migrations transactionally? And if it doesn't, do you control the migration, the transactionality of the migration through those two Kubernetes parameters? So you cannot put two there, because if you start two new containers of the new version, it will break.
So what Flyway does is basically when it tries to apply the migration, it locks the database. Well, not the database, but the table. So normally, when a pod starts a migration, no other pods can start the migration at the same time. So there might be some delay for sure. But if you are an old pod, and because I'm doing the rolling upgrade only one by one, that's fine. Here, it's not very useful to have a max surge, a huge gap between the max surge and the max unavailable, because the more pods you add, they will just get deadlocked to wait for the first one to finish the migration. But yes, it will lock the table, so basically everything will be fine. Good question. Other questions? It was so clear. I'm always a bit afraid when there are no questions. It's either the best talk you have ever seen or the worst one, and then you are too polite to just go away. Thank you very much.